Okay, so on this problem, I've got a stress-strain curve. So we've got a tension test of this magnesium alloy specimen, right? So I've got the stress-strain diagram. It wants me to find the modulus of elasticity and then the yield strength using the 0.2% offset method. So the first thing I'm going to do is I'm going to go ahead and find that yield stress. I'm sorry, the modulus of elasticity. And the way I do that is basically the slope of that initial perpendicular line. So you can see that it starts at 0, 0, okay? And I'm basically just finding the slope, which is the rise over the run. So I'm just going to choose another point to find the rise over the run, and I'm going to choose this point right here, which is at 10 KSI, okay? So my modulus of elasticity here is then going to be 10 KSI over, that's the rise. The run on this one is approximately 0.001. It looks about 6 in there. And you're approximating this, not going to be exact without having exact data, okay? But that is essentially the slope of that line, that rise over run line. And the answer for that one is 60 to 50. And that is KSI. Okay, so that is the modulus of elasticity of this tension test. Again, it's that slope of that initial proportional linear line. Now, the problem here is there's not like a definite yield point like there oftentimes is with steel. So what we do is we do this 2% offset, which means we come over to the 0.2, maybe. Okay, and we basically draw a line up from the 0.2%, which is 0.002 strain, at that same, excuse me, at that same slope, and we see where it intersects, and we approximate that as the yield stress. So, and again, this is again approximate. I'm drawing this line more or less. So right there becomes my yield stress. So that yield stress, and again, this is just an approximation. Okay, but using that 2% offset, and that's going to be, I don't know, we'll call that 24 KSI. Okay, so again, once you get the stress-strain diagram, you can easily, using the slope of the proportional part, you can find the modular elasticity, and then the yield point, the yield stress is either well defined as the point where proportion stops going, or I can draw a parallel line up from 0.2% strain and see where it intersects and use that as my yield stress.